Hello class, these are our Algebra 1 notes for section 225, solving word problems with systems of inequalities. So here's our word problem. A family has at most $25 to spend on activities at Fun Zone. It costs $10 an hour to use the trampolines and $5 an hour to use the pool. The family can stay less than 4 hours. So we want to write and graph a system of inequalities to represent these constraints. So let's see what we have going on here. So we've got two different activities. So they can use the trampolines, they can use the pool. So it seems like hours on the trampoline and hours on the pool are two different things, right? So the family is going to Fun Zone. They could spend maybe an hour on the trampolines, and then they could spend, it says less than 4 hours. So maybe like 2.5 hours at the pool, right? So they've got that time constraint where they can only say so many hours, but then they also have a money constraint. So like being on the trampolines is more expensive, so they'll have to do less of that. So it looks like we've got two different inequalities that we could write here. We've got one for money and we've got one for time. So if we're looking at the money equation, so I'm going to talk about how there's a money equation and there's a time equation because both of those are constraints. So the money equation is we've got $10 an hour for trampolines and $5 an hour at the pool. So let's say trampolines is X and pool is Y, and I'm just picking them in whatever order they're used in the problem. Then that means my money spent on trampolines would be 10 times X. So if I have 1 hour, it's $10. If I have 2 hours, it's $20. So we're multiplying the dollars times the number of trampoline hours. So hours of using the trampoline is going to be X. And then we want to total up all of our money. $5 an hour for pool, so 5Y. And at most $25 means it could be less than or equal to $25. So we've also got a time equation. So we have less than 4 hours. And I could see like maybe at 4 hours, everyone's going to be too hungry to play anymore. Or you can only leave the dog at the house for 4 hours or he'll chew something up. I don't know. So it seems like the other thing that we have going on is that X plus Y also has to just be less than 4. So let's go ahead and graph our system here. So we've got a really big space for a graph. So I'm going to say that just counting 1 square as 1 is probably not going to really fill up our graph. So let's say 2 squares is 1. So this is going to be 1, 2, 3, 4, 5. I don't really know how far to go. So let's just do 2, 3, 4, 5, 6. We're still not using up our whole graph, I don't think, but it'll be a little bit better than what it was. And again, for our x-axis, it's hours on the, what was X? Trampolines. Hours on trampoline. And then our Y was hours at the pool. And then maybe we call this like Fun Zone. So when I am trying to graph 10x plus 5y equals 25, because really I'm looking at where to graph the line, and then I'm going to do some shading. If I want to find my x-intercept, I would let y equal 0, and that means I'd have 10x plus 5 times 0 equals 25. So the 0 part zeroes out. I have 10x equals 25, which means x equals, when I divide both sides by 10, I get 2.5. So 2.5 would be right here. This would be my x-intercept. When I am finding a y-intercept, I am letting my x equal 0. So 10 times 0 plus 5y equals 25, which means 5y is equal to 25. Divide by 5, y is equal to 5. So my x-intercept was at, it was where my y was 0, my x was 2.5, so it was a 2.5 comma 0. My y-intercept is where x is 0 and y is 5, so that's going to be 0 comma 5. So let's go ahead and make that point. And I think I want both of these in a color. So here's my 2.50, and my 50. And it looks like we could have made our scale much bigger, but that's okay. This is less than or equal to, so I do want to connect them with a solid line, not a dashed or dotted line. And I want to be shading, it says less than or equal to 25, so I'm going to be shading below this one. Let's go ahead and take a look at our second equation. So our second equation is x plus y less than 4. So if I say it's equal instead, because I am, again, graphing the line, and remember it's going to be a dashed or a dotted line, and I have x equals 0, or actually let's do y equals 0 first. So if I have y equals 0, x plus 0 equals 4, so my x is 4. So when my, 4. So when my y is 0, my x is 4. That's 4 comma 0. So let's go ahead and make that point. So here's 4, 0. And then when my x is 0, my y is going to be 4, right? 0 plus y equals 4. So my y is 4, so it's going to be 0 comma 4. So my y-intercept is 4, my x-intercept is 4. And this one is less than or equal, just less than, not or equal to. So I want to connect them with a dashed line. And then for this one, I'm going to be shading below as well. So I don't really know what color to use. Let's use this one. So I'm shading below on this one as well. So everywhere that they overlap would be a solution, right? So that means this would be a solution, and this would be a solution, and this would be a solution, but not anything on the dotted line, right? This isn't going to be a solution right here, because that would be exactly 4 hours, and it needs to be a little bit less than 4 hours. Again, maybe it's a kid thing or something. This would be a solution right down here, but it seems like if I'm only going to stay half an hour on the trampoline, half an hour in the pool, like what kind of fun is that, right? We want to stay probably a little bit longer than that, but anywhere within this double shaded region, and I'm kind of now going back over my double shaded region, any spot in that region is going to be a solution. So this is what we want to look at today. We're looking at solving systems and word problems again. So as always, if you have any questions, please make sure you get help and that you ask.